When a well is open to production, a pressure wave moves out into the reservoir, and the pressure in the affected region continuously decreases with time. At any given radius, the pressure drops rapidly at first, and then stabilizes with time. The pressure at the wellbore follows the same pattern. For example, the bottom hole flowing pressure profile for both a 200 barrel per day well and a 500 barrel per day well are shown here. In addition, the average reservoir pressure normally decreases with time as the reservoir is depleted of its fluids. When the pressure drops below the bubble point of the oil, gas begins to form. From our earlier discussion of effective and relative permeability, we realize that the presence of gas inhibits the flow of oil. Soon after flow has begun, the bottom hole flowing pressure approaches a stable value. And when we use this stable value in our calculations, we can apply the equations of steady state flow to our performance analysis. The difference between the average reservoir pressure and the stable bottom hole flowing pressure at the wellbore is called the pressure drawdown. This wellbore flowing pressure produces a flow rate, Q, and defines the productivity index, J, for the well. J is in stock tank barrels per day per PSI of drawdown. The productivity index represents the dynamic response to flow of the reservoir and its fluid properties within the drainage area of a specific well. It defines the relationship between flow rate and bottom hole flowing pressure for a given average reservoir pressure. The productivity index is constant when flow parameters like permeability or pressure are constant. When bottom hole flowing pressure is above the bubble point, the productivity index will be constant. As the pressure drops below the bubble point, the productivity index will decrease as gas comes out of solution and inhibits flow.